This is question 9, the last question on the N25 mock paper 1. We have a quadratic function. The roots are -3 and 1. F also passes through the point 3, 3. And you're asked to find the values of A, B, and C. Pretty straightforward start to the question. This is another proof that you should keep going, even if you are stuck at the end of question 8 earlier, because the first part of question 9 should always be accessible. Part A. We know that f has roots -3 and 1, so we can deduce that f of x is a times x plus 3 times x minus 1. F also passes through the point C, 3, 3. So f of 3 is equal to 3, and therefore this has to be true, or A is 1/4. This function f of x is not in the form that you are asked to give. But all you have to do is expand and simplify your expression. And that gives you the final answer. Easy, 5 marks. Part B. Let's write down g of x. And try to simplify this just a little bit before we keep going. Cool. We know that g of x is positive for all real values of x. What does that mean? Let's look at a potential graph of g. I said a potential graph because you don't know the value of k. Because the coefficient of x squared is 1/4 or positive, we know that it is a parabola opening up. So it can either be this or something like that. But g has to be strictly positive, so it cannot be the first curve. That means it has to be the second curve. If it is the second curve, it also means that g of x equals to 0 has no real roots. And thus, the discriminant has to be strictly less than 0. So the discriminant is 1/2 plus k squared plus 4 times 1/4 times 9/4. And this has to be strictly less than 0. And we should all know how to solve this inequality. And this would be your final answer. Part C. This is the trickiest part of the exam. We have a function h of x. The line y equals to 3 intersects the graph of h at C and D. So let's draw that line, shall we? Here we go. So this is the line y equals to 3. We know the vertex of h lies on the line y equals to 6. Sure, 4, 5, 6. So the vertex has to lie on this line. We know that the 4 points A, B, C, and D form a parallelogram. So we have A, we have B, we have C. One potential position for D is over here. That would give us the parallelogram ABCD. However, this is not the only possibility. A second potential coordinates for D would be over here. And that would give you the parallelogram A, C, D2, B. The 4 points are the 4 points from a parallelogram, but it's not parallelogram ABCD. Know the distinction. So what are the coordinates of D1 and D2? We know that D1 has coordinates -1 and 3. D2 has coordinates 7 and 3. We know that the parabola also passes through point H. So that means that if the vertex is over here, for example, this is vertex 1, one potential graph for F would look something like this. Another one would look something like that. And that would give us two possible functions H. So let's look at the first scenario. Let's say that the vertex lies on y equals to 6, and it also passes through the points D1, -1, 3, and C, 3, 3. This means that the axis of symmetry is x equals to 1. Therefore, we can deduce the coordinates of the vertex, and thus we are mostly done with our parabola. Point 3, 3 lies on the curve, therefore just a bit more algebra. And you're done. Similarly, in case number 2, D2 has coordinates 7 and 3, C is 3, 3. Axis of symmetry in this case is going to be x equals to 4. No, sorry, x equals to 5. The vertex is 5, 6. And you would actually end up with the same value of m. But we can also show it more formally. And voila. So those are your two possibilities. Either h of x is equal to -3/4 of x minus 1 squared plus 6, or it can also be -3/4 x minus 5 squared plus 6. And this is the end of the last question of the paper. I hope you find it a challenging paper, but a very useful study aid for your revision.